1. So unfortunately, Ali has left us, which leaves two people who don't know physics trying to teach physics. But let's try. So 7 is define capacitance, and if you remember, the formula was Q is equals to CV. Yeah, in physics में formula बस words में लिख लो, it really does help. So basically ratio of charge stored to potential difference. That should be good enough. 3 capacitors of capacitances C1, C2, C3 are initially uncharged. They're then connected to a battery. The battery applies a potential difference V across 3 capacitors. Show that the combined capacitance C of the capacitors is given by this. So yeah, ये हमें prove करना है. And we know that the voltage divides across the 3, but the charge remains the same in series. सही बोला मैंने?
हाँ.
So if you rearrange this to give you voltage, voltage is equals to Q upon C. So yeah, and Q is the same, and voltage would vary with respect to the capacitance, but Q will always remain the same because the charge is the same in series. That's the idea. So yeah, and if you remember, you recall with regards to हम जब resistors का भी करते थे, तो voltage always divides, current would remain the same, so charge would remain the same. That's another way to remember it. So what we can write is आपने लिखा कि V1 plus V2 plus V3, which is a potential difference across 1, 2, and 3, should give you overall V, and then you can simply substitute this. So this is Q upon C1 plus Q upon C2 plus Q upon C3, C3 sorry, and आप Q को common ले लो, cancel कर लो, and you're done. Battery of EMF 12 volts and negligible internal resistance is connected to a network of 2 capacitors and a resistor. The capacitors have capacitances of 200 microfarad and 600 micro whatever. The switch has 2 positions. So basically, ये आपकी switch है. A and B. The switch, the switch is moved to position A. सही है, तो मतलब आपने ये कर दिया basically. You moved it to position A, so the resistor isn't going to be taken into account. That's the basic idea. Wait, yeah, because ये circuit बेकार हो गया, आपका ऐसे जाएगा. Calculate the combined capacitance of the 2 capacitors. So these capacitors are attached in series, and as we just saw, series में ये होता है. And another way to remember it is resistors in series I used to add, and resistors in parallel used to do the 1 upon bari tafri. In capacitors, yeah, in capacitors it's just ulta, like this is the ulta of resistors.
Ali is back.
Yeah. So 1 over C is equals to 1 upon 600 micro जो है 10 power minus 6 plus 1 upon 200 10 power minus 6. You simplify and you'll get the combined capacitance, which I'm lazy, so I'll just take from the marking scheme 150 micro. Achha, don't do this because उसे micro में ही चाहिए. इधर micro में ही चाहिए. The charge on the 600 microfarad capacitor. So charge is Q is equals to CV. And we know that the potential difference will divide in such a way that अगर इस तरीके से देखा जाए, it is inversely related to the charge. तो वैसे to the capacitance, sorry. So वैसे तो 1:3 का ratio है for capacitance. However, यार किसी तरह की तरफ से शोर आ रहा है. Okay, so ratio of capacitance is 1:3, which means because V and C are inversely related, this will go 3:1, right? तो 3:1 लगा लो. कितना होना चाहिए आपका? 3 and 3:1 क्या होगा आपका? Basically 3/4 into 12, 9 and 3. So इसके across there will be 9 volts. इसके across there will be 3 volts. That's the idea. And then you can use it here. Q is equal to CV to 600. So you for the 600 one, you take the 600 जो capacitance है into 10 power minus 6 into 600 के खिलाफ के across क्या था 3 volts, and you get your charge. The potential difference across the 600 microfarad capacitor, okay, that is interesting because we calculated like this. हमने या तो टू में कुछ different तरीके से करना होता, या तो आप या तो you okay, so 2 is fine by this idea as well. However, the way you can also do 2 is through the idea that the charge doesn't divide, so charge is constant and you have voltage, so you could simply be like overall capacitance into voltage. So overall capacitance of 150 है micro, 150 into 10 to the power minus 6 into overall voltage, which was 12. You could do it like that. सही है. But
by the way, marking scheme accepts both of those answers.
Yeah.
So obviously, what is the first one because अगले पार्ट में जो पूछे वो पहले नहीं निकालना चाहिए.
हाँ, हम we were a little over efficient, हमने पहले से निकाल लिया. AC explanation हमने कर ली है. 3 volts होगा because again just ratio देख लो of the capacitance and charge is in the opposite ratio. It's basically because inversely related. The switch is now moved from position A to position B. Calculate the potential difference across the 600 volt, 600 whatever capacitor when it has discharged 50% of its initial energy. So to get some clarity, we'll have to look at this. जरा सही से. गाने किधर से बज रहे हैं यार? What on earth?
म्यूट कर देता हूँ सही.
हाँ. Okay, so क्या था अभी switch B की तरफ है. Wait. That seems fishy. Circuit ही connect नहीं हो रहा.
क्या हुआ?
When we say switch is towards B, how do we go about that? We need the circuit to connect though.
आप तो connect कर लो ना.
Is it like this? नहीं.
No, I think the बीच वाला उसका ट्रैक है ना. सर्किट कंप्लीट हो रहा है, तुम देखो एक सेकंड, मुझे भी लगा था.
कहाँ कंप्लीट हो रहा है?
नहीं
कंप्लीट तो नहीं हो रहा. अरे स्मार्ट बॉय, Ali dead. Ali. Let's look if the question helps. Question में क्या था कि hello. Yeah. चलो, Ali ने कुछ बोला तो सही, but I can't hear him. Okay, the switch is now moved from position A to position B. Potential difference, but it's discharging, so maybe if you go like this, and that is since the circuit is not being completed, that is why the capacitor would discharge, right? Does that make sense?
Yeah.
So yeah, the circuit is not being completed, but the battery isn't really helping you now. However, the capacitor will now start to begin to discharge. And we're saying isne 50% of its initial energy. And if you remember, if you used to draw क्या कहते हैं, Q is equal to CV था ना, तो if you draw Q and V and you have like C, so yeah, the energy was basically the area under the line, which is basically half into VQ, right? That's energy. You can write half VQ, and when it is discharged, yeah, VQ हम निकाल चुके हैं, and you want when it is discharged 50%, so you want all further इसे half कर लो तो ये 1/4 हो जाएगा. सही है, and you want to calculate the potential difference across 600 when it is discharged 50% of its initial energy. Yeah, so a simpler way to do this is just to calculate the initial energy and then just go from there. So yeah,
I think it's sahi hai, because you need a potential difference. B is potential difference, right? So
yeah,
you know charge.
But we don't have energy though, right?
No, you don't have energy.
We don't have. So let's calculate the initial energy. And this is basically why. So they want the potential difference across this resistor, for a reason, they wanted the charge, whatever this value was. Let's pick it from the marking scheme. In fact, charge
Charge 1.8.
1.8 into 10 to the power minus 3. So 1.8 into 10 to the power minus 3. Sorry, this is 1.2. So this will give you energy, right? Then what do? You halve this. So you divide this upon 2, and then you input it again into the equation, where your charge and all is the same, but you just calculate V. But you keep V as as the unknown. सही बोला मैंने?
Why would charge be the same?
Why would charge be the same? No,
The only thing that's going to remain constant is going to be capacitance.
My bad. So you, instead of writing VQ, you could.
Can use CV square? That would be better.
So Q is equal to CV है, so you just replace this here. So the energy का आपका half V square C आ जाएगा, सही है? So C is the same. So you can input C.
हमारा हो गया ना अब energy निकालने की जरूरत.
Yeah, निकालने की जरूरत नहीं है. Energy की जो भी value है, divide by 2 कर लो, input into this particular formula, and you'll get the answer. So yeah. So state 2 effects of negative feedback on the gain of an amplifier incorporating an operational amplifier. State 2 effects of negative feedback. Op amps किसको आता है? Negative feedback से क्या होता है? Hello. Ali.
I think इसमें is this the saturation वाला?
एक तो एक गेन उल्टा हो जाएगा, रिवर्स होगा, और सेकंड के गेन रिड्यूस होगा.
Gain reduced because it goes a little back. But खैर ये marking scheme check कर लेते हैं. So it decreases gain. So definitely decreases gain. Increases bandwidth, decreases distortion, increases operating stability. So I get the idea behind decreases gain because some of that just goes back into the negative terminal. So as feedback. So V out isn't as large as it normally could be. However, how do you increase bandwidth?
Bandwidth, because there is a larger range of values before saturation is achieved.
There are a larger range of values before saturation is achieved. And how is that so?
क्या?
How? Can you explain why?
बड़ी मतलब क्या कहते हैं वो जाता है ना, यही बैंड इस चीज से ताल्लुक है, लेकिन इस चीज का जो मैं बोल रहा हूँ मैं क्या कहते हैं, यही ना क्या है उसका गेन से उससे ताल्लुक. एम्पलीफायर जो है वो वही रिवर्स जा रहा है ना, क्या कह रहा हूँ?
I mean, I understand the idea is it you know, if it what alternatively you could go with, if it decreases gain, so you kind of avoid saturation wala aspect, so distortion come hai, because when you saturate then you lose information, right? But if you're decreasing gain, you're avoiding saturation, so you're decreasing distortion, so that's something you could go with.
That makes sense.
Sad. And the reason why this was wrong, Vese, is because gain is inverted when your V input is in the negative terminal. If the feedback is negative, that is non-inverting. That was our bad, right? अगर input जितना जा रहा है negative terminal में, फिर होगा like inverting. So ideal operational amplifier is shown in figure 8. Has a voltage gain of this. Again, gain is V out over V in. So yeah, complete the circuit diagram and understand this has to be a non-inverting amplifier. Why? Because you in जो भी आपके gain की value positive 5 में आ रही है, inverting में negative में आ जाता है because it's inverted. So yeah, so you make another resistor here. हमने ऐसे इसको join कर लिया. This goes as feedback into negative. ये आपका इधर positive में लग जाता है. This would be your RF. वैसे this would be the other resistor, whatever you want to call it.
Rin.
Yeah, Rin call कर लो. So yeah, calculate the resistance of any additional resistor you have drawn in figure 8.1. Iska yaar formulas for op amps you should learn them. It just makes life much easier. So you have V out over V in, that is gain, 1 plus RF upon R in. And I see derivation is also very interesting वैसे, but not
डेरिवेशन यही है, इसमें भी करंट है.
डेरिवेशन इज जस्ट कि वो वोल्टेज डिवाइड कैसे होता है.
हाँ,
for
करंट
voltage
इक्वल करना है.
voltage
तो
divider. But yeah, but like that's उसमें घुसेंगे तो तेरा complicated हो जाएगा. So you have 7.2, and I'm not converting this because they also want it in kilo ohms upon X. So then you have 4, you have X is equal to 7.2 upon 4. And you just add whatever value you get. So yeah, so figure 8.2 shows the variation with time of input potential V in. On figure 8.2, draw the variation with time of the output potential V out. So yeah, so you know that gain is 5. Nahin. Yeah. So if
V0 upon Vn, V out upon Vn is 5.
so V out upon V in is 5, which basically you can, to simplify, you can write it as 5 V in, right?
And Vn is decreasing, so V out has to increase by the same amount.
Yeah. So and let's make life easier for us. If जिधर V in is क्या कहते हैं, नहीं तो से एक कोई अच्छी सी वैल्यू ले लें, पिक कर लेते हैं. Let's pick a value. Let's pick this. ये क्या होगा आपका? You'll have to look at it a bit. If this is 4 and this is 3 and this is 2 and this is 1, this would be 1.5.
वैल्यू को लेना एक सेकंड. 3 वाली वैल्यू को 5 से मल्टीप्लाई करो, 15 का अच्छा नंबर है. और इट्स सिंपल 15 से ड्रा करना विद सेम ग्रेडियंट.
Sorry. Okay. Wait. Let's go with a simpler number. Let's go with 3. This is 1, right? So this should be when it gets, this is V in, and we know V out is 5 into V in. So at time this is 3 milliseconds. Instead of 1, you'll have 5.
Yeah.
So yeah.
At time 0, 15 होगा.
And at time 0, 15
तो 3 है देखो.
Okay. But yeah, you don't need to, if you have a scale and you have, you know, a good, you can just draw it.
Gradient of 5, yeah.
Whatever, ऊपर चला जाएगा. मैं ऐसे नहीं, या 15 पे hit कर लेगा. The other thing to take into account here is your this. So the idea is that this is where saturation is achieved. So it can't ever go above 8 volts. So here, to show that, yeah. So 8 kya hai? This is 9. So this would be 8. So you'd show this
and cut off that red part.
Yeah, instead, so the blue is going to be your actual curve, because it can't ever go above 8 or below -8, because those are the supplies. Okay, on figure 8.2, draw the variation with time. Okay, ye kar liya maine, kitni baar karenge, sahi hai. A particle of charge positive q and mass m is traveling with a constant speed of this. In a vacuum, it enters magnetic field of flux density. Flux density is V of this. Say the magnetic field direction is perpendicular to the initial velocity of the particle and perpendicular to and out of, that's important, out of the plane of paper. Bahar aa raha hai. A uniform electric field is applied in the same region as the magnetic field so that the particle passes undeviated through the field's state and explain the direction of the electric field. So I believe pehle left hand rule se you can figure out magnetic field se kidhar force lagegi, correct? So positive, so with left hand rule aapka, if you look at it like this, left hand rule, ye and ye jo bahar nikal raha hai. Okay, in fact making it is a bad idea. Just use your own hands. हमने ये बाहर निकाल दिया, ये ऐसे है. So downward लग रहा है. Force, magnetic field is downward, magnetic force. Now you want to figure out, you want a force that is upward. You want to, and it so obviously upward आप negatively charge कर दोगे नीचे positively कर दोगे because this is a positive thing, only then you'll get an upward force. So the direction of the electric field will be upwards, positive to negative. Make sense? And you basically write this in word, you write upwards, you write like so that, you know,
To oppose.
yeah, to oppose magnetic
field is
force,
downwards. Magnetic force is downwards.
yeah,
So,
which is downwards. So yeah, calculate the magnitude of the electric field strength, explain your working. The idea here is that you want to the particle to pass undeviated, so you want F m is equals to F e, correct?
Yes.
F m क्या होता था?
yes.
BQV, force due to electric field, F is equals to EQ.
Don't really need to write EQ, but कहाँ से Q कर देंगे?
So yeah, so electric field would be equals to B V, and you have B. This is B. You have
V
V.
also.
You have V. You can multiply them. By explain your working, the
We have both values.
Sorry. Sorry. Hello.
Explain your working भी है मेरे ख्याल से नहीं.
Explain your working. They just want one statement. So you just what we wrote here
They're
basically.
both equal. Just write that both
This
forces
is an
are
actual
equal.
statement.
Yeah.
This is an explanation of the work. That's all.
Yeah, basically, so they both force of magnetic field and force exerted due to the electric field have to be equal in order for the electron to in order for the positive charge to pass undeviated. That's the idea.
Yeah.
The electric field is now removed so that the positively charged particle follows a curved path in the magnetic field. This path is an arc of a circle of radius 4 because magnetic field has circular motion. उस तरीके से उसका motion होता है of the charged particle. Calculate for the particle the ratio Q over M. So the idea here is that Ali, correct me if I'm wrong. So the magnetic force provides the centripetal force.
Yes.
Yeah.
So yeah, so magnetic force is BQV. Centripetal force is MV square over R. So we can cut V, and you want Q over M का ratio, which would basically V upon R आपको दिया हुआ है. So you have V from the question, you have B from the question, and R इधर आपको दिया हुआ है. You would input that, and you'd get Q over M. सही है? Again, just make sure अगर mass kg में है, make sure this is in meters. Like, just do the basic things correctly. The particle has a charge of 3e, where e is the elementary charge. Elementary charge of the 1.6 into 10 to the power
You
minus
get that
9.
from up the above.
हाँ,
You don't have to remember it.
Yeah, ऊपर लिखा हुआ है. Use your answer in C to determine the mass in U of the particle. So basically, what you're doing, you
have Q upon M.
Yeah, you have Q upon M. You're given Q upon M is a particular value, whatever you calculated here. You just input Q as 3e, and you have to calculate mass.
Yeah.
So yeah, mass in U. So basically, आपकी जो भी value आएगी for 3e would be upon this. This would give you mass in kg, I believe, right?
The mass is in U, isn't
Yes.
there? Like.
Yeah, this would give you mass, in kg, right? Then you have to convert it.
And then you convert it.
Yeah, and conversion U ka is like, so like 1 U, for example, is something.
By
Yeah, but ratio se kar lo, like 1 U is something into 10 to the power something. So XU would be whatever value you get, and then you just do it with the ratio method. You go.
The answer is 7, by the way.
Good see.
For the next part.
The particle is the nucleus of an atom. State the number of protons and the number of neutrons in this nucleus. Okay, so again, is this a positively charged particle?
No, doesn't matter. It's a nucleus. It's a nucleus is obviously positive. Like, doesn't really matter. Electrons पूछेंगे.
हाँ, that no, but it would help us figure out the number
The
of
particle has a
protons.
charge of 3e.
3e. Okay. I'm sorry, I think I'm missing something. So we know 7u तो है, we know तो protons and neutrons को मिला के तो 7 होगा.
अगर 3e है इसका मतलब उसमें इलेक्ट्रॉन्स 3 होंगे.
The particle is a nucleus of an atom, यार atom है.
Okay. Of an atom, not an ion, basically.
Yeah.
Okay, so if it has 3e, मतलब like 3 electrons and the 3 protons हो जाएंगे, whatever.
3 electrons नहीं है. 3e just means charge 3 है. It can be positive also, by the way. It's probably positive. So
Yeah.
the negative.
नहीं ना, atom है, atom बोल रहे हैं.
Atom
The
है.
particle is an atom.
Hmm.
Just forget it. Yeah, 3 proton, 4 neutron.
Yeah.
3 protons, 4.
That's the idea. So you have, या तो तुम 3 electrons से 3 protons देख लो या तो directly देख लो.
ये मेरे से पता होना चाहिए ना, नहीं?
Sorry?
3 proton का कौन सा एलिमेंट होता है?
नहीं, प्रोटॉन का एलिमेंट का नाम नहीं लिखना. मुझे पहले ये था एलिमेंट का नाम पूछा ही नहीं. और उसकी केमिस्ट्री नहीं है, सब प्योर टेबल नहीं मिलती.
सही है.
Periodic table. Okay. Small coil of wire is situated in a
I
non-uniform.
think what we were just using was the fact that protons and neutrons are roughly equal in the lighter elements. They are roughly equal, but if we had to have someone either of proton or neutron to be greater, it would be neutrons.
But okay, that's interesting, but that's not the how we calculated this,
don't
right?
need. नहीं, एक मैं बताता हूँ, इसको थोड़ा ऊपर करो.
ऐसी भी हाँ सही है. अच्छा 3 ही है. हाँ सही है.
इसका मतलब पहली बात पॉजिटिव है, इसमें 3 प्रोटॉन्स हैं.
हाँ समझ गया.
तो बाद में 3 हो गया, 3 4.
हाँ ऐसी बोल रहे हैं कोई चीज.
मतलब हाई लेवल को ज्यादा ही हाई लेवल चीज हो गई. लाइक लोग सुन के परेशान हो जाएंगे. लाइक दैट्स द इशू. So a coil consists of 40 turns of wire. सही है, 40 turns of wire and moves with a constant speed in a straight line. But understand this is a non-uniform magnetic field, so magnetic field could be changing. So the coil has displacement x from a fixed point. The variation with x of magnetic flux in the coil is shown. कितना flux लग रहा है. The coil is moved at a constant speed between point P and the point where x is equals to 3 centimeters, and where x is 3 centimeters, magnetic flux is 3. Calculate the change in magnetic flux linkage of the coil. So magnetic flux linkage क्या होता था?
Multiply by number of coils.
N, yeah, basically. So for change is like 5 minus 3, so that's 2 into कितने number of turns है? 40 gives you 80. However, the only issue here is they're asking in WB either 10 power minus 6 hai. So here the change would be into 10 power minus 6 and then you do it into 40, which would give you a slightly different answer. The EMF induced in the coil is this. Determine the speed of the coil. So the idea here is that EMF induced in the coil is rate of change in flux of, say, you have your EMF into 10 power minus 4. You have your change in flux. So हमारे पास है change in flux linkage. Let's just call this
8 into 10 to the power minus 5.
Let's just call this box. Sorry, so box. You need
8 into 10 to the power minus 5 है ना?
हाँ 8 into 10 to the power minus 5 है. दादी क्या काम कर रहा है?
Minus 5. So let's just write that correctly then. 8 into 10 to the power minus 5. That is change in magnetic flux. You want a change in time.
Yeah.
And time कितना? Okay, so
time यही से आ जाएगा ना? Time formula से निकालना है ना?
Yeah,
time निकालो, distance divide.
Yeah, so you calculate time, and you know that it's traveled 3 centimeters here. So you use the formula speed is equal to distance upon time, and you calculate speed. Yeah. Sketch the variation with X of EMF E induced in the coil for values of X from X0 to X6. So yeah, so for this, it's really useful if you put the above curve in front of you. And you have to look at it in gradients basically, because
Negative gradient.
yeah, so here I forgot Lenz's law. Lenz's law means minus. So gradient ko dekho and just flip it. So if you look at the gradient for this, that is change in y over change in x. आपका 2/3 आ रहा है. But again इसमें properly आपको देखना पड़ेगा. So like if you can calculate this सही से, change in, where's my calculator? So change in y आपका जो था, that was 2 into 10 power minus 6. 2 into 10 power minus. Guys, इसमें हम change in flux लेंगे या change in flux linkage लेंगे?
Doesn't matter. हम सिर्फ change in flux लेंगे वैसे, linkage नहीं लेंगे. EMF is directly proportional to change in flux. Right?
Okay, Ali, can we get some verification?
Ali, message करना बंद करो या बात कर लो.
क्या होगा?
Will we take change in flux or change in flux linkage for Faraday and Lenz's law?
Linkage किस चीज के लिए बोल रहे हो?
For this.
ग्राफ जो बनाना है E का हमें.
Because we would want to plot values on the
Why do you
y-axis.
need to calculate anything? First of all, you just have to look at the ratio of how the gradients change.
वही ना, ये रेशियो है, प्रोपोर्शनल है, doesn't really matter.
वैसे भी हाँ, और करना होता है तो मैं कैलकुलेट करना था तो लिंकेज इस्तेमाल करते हैं. ऐसे ही बता रहा हूँ. कॉइल की बात की जा रही है, लेकिन अगर नई बात हो उस चीज की छोड़ दो. लेकिन हाँ, रेशियो इस्तेमाल करना है हमें बस. ग्रेडियंट जो डबल हो रहा है ऑपोजिट डायरेक्शन में.
Okay.
देखो कितना by कितना gradient change हो रहा है.
Yeah, but like ideas here with 2 marks you can get away with that, but at times when they're giving 3 marks for it, then you do want to give some value of E on the side, ताकि you know, because at times
डबल करोगे ना, कह तो रहा हूँ.
हम कोई भी arbitrary value, doesn't matter 1 law or 2 law, I don't think it matters.
Okay.
ये देखो ना, ये देखो यहाँ देखो ग्रेडियंट डबल हो रहा है 3 के बाद, तो EMF की वैल्यू भी डबल होगी.
Good scene. Okay, so the first gradient is negative something. When you negative is a negative constant, formula में डालोगे because sign change हो जाता है इधर because of Lenz's law. So you have a positive constant till 3. Well, so the बड़ा बन गया. But yeah, you have a positive constant till 3 is a particular amount, and then now the gradient is a positive constant of a magnitude that is double than what was there before. And because you put it to Lenz's law, sign flip ho jata hai, so now it is a negative constant for the rest. And the idea here, if this is x, then the magnitude here should be 2x, because that was what we saw from the.
And we have that. We have x is 5 multiplied by 10 to the power minus 4.
Yeah, and we can, if you want, you can write that on the y-axis.
By the marks are very lenient and they even accept that it should just be greater. Double भी जरूरत नहीं.
अच्छा सही है.
क्या मार्किंग स्कीम में क्या लिखा हुआ है?
तो बोला बस greater दिखाओ gradient को. मतलब वो वैल्यू को थोड़ी बड़ी होनी चाहिए उससे.
Yeah, so basically
डबल इसलिए क्योंकि हमें पता है gradient डबल है, सही है.
हाँ. 2 मार्क का 3 मार्क का होता तो 100 से ज्यादा होता. This meeting, I don't think we can complete it in this meeting. So let's start a new one for the next few questions.